Hello, my dear students. Good day to everyone. Welcome back again to our series of discussion in general mathematics. Before I'm going to start again, may I invite you again to please subscribe and click the notification bell so that should there be any future discussion in general mathematics or other topics in math, you will be reminded or notified. Once again, I'm Agi Pajaos. The focus of our discussion today will be exponential function as continuation of series number 8. So we are now in series number 9 under the exponential function. Okay, so our focus in here would be the properties. So for us to understand the properties of the exponential function, we have to familiarize again our self with the form of the exponential function, wherein we have in here the f of x is equal to b raised to x. And that when we are going to understand this one, we need again to recall the possible values of the b, which represent the base, that your b must be greater than 0. Okay, again, your b must be greater than 0, and your b must not be equal to 1. So you will notice in here the possible values of your base or your b must be greater than 0. That could be zero point 0.1, zero point 0.5, 0.75, 1 half, 1 third. So you will notice this number are all greater than 0. But there is the colatilia in here that your b must not be equal to 1. Meaning to say you can have the value of your b, which is 2, 3, 4, 5, but not equal to 1. Now what about the values of x? The values of x in the exponential functions are all real numbers. Meaning to say, your b can have a negative number, your b can have a value of decimal number, your b can have a value of a whole number, and even 0. So it says in here, one of its property, the domain of the exponential function is the set of all real number, meaning to say the value of x are all real numbers. Another in here would be the range is the set of a whole number that starts from 0 to positive infinity. Another one in here is an exponential function is considered to be a one-to-one function. Under the one-to-one function, we make use of the horizontal line test, wherein when we are going to use the horizontal line test, you will notice that there is only one intersection that the horizontal line passes through. Another one would be the y-intercept. The y-intercept is always at 0 and 1. In the exponential function, one of its property, the horizontal asymptote is located at y is equal to 0. Let's continue. So it says in here, construct the graph of the function f of x is equal to 1.5 raised to x. Again, how do we graph the function? When we graph the function, we follow these steps. We use tables. After having the tables of the possible function, we determine the domain. So if we determine the domain, the next would be evaluation of the function, wherein we make use of the possible values of the domain. And so after that one, we come up now with the values of the function, which is the range. So let's continue. I have in here the table. So f of x is equal to 1.5 raised to x, wherein in here, I will be determining the domain. The domain will be all real numbers, or the values of x are all real numbers. So I will assume these values of x from negative 2 to positive 4. Values of the x or the domain from negative 2 to positive 4. Now we will be evaluating now the function. But before we are going to evaluate the function, try to take a notice with our function f of x is equal to 1.5 raised to x. Because so after this one, I will be giving a similar equation or similar function, but the exponent is negative. Try to compare the two kind of functions I will be illustrating. And so when we are going to have the evaluation of the function, we have in here the f of x is equal to 1.5 raised to x. Now, when we are going to evaluate, we say, what if my x is negative 2? And so I will be changing my x in here with negative 2. What would be the result? It will give me a result of 1.5 raised to negative 2. And the result will give you that is 0.44. So I will allow you first to prepare your calculator so that you can follow immediately this computation. I'll give you 10 seconds. Okay, let's continue. So if my x is negative 2, my y would be 0.44. Okay? Ayan. The next one would be, what about if my x is negative 1? What would be my result? My result would be 1.5 raised to negative 1 will give you a result of 0.67. So it will give you a result of 0.67 that is in the table immediately. Now another one would be, what if my x would be 0? What would be the result? So I will be having an exponential number which is 1.5 raised to 0. It will always give you 1 as according to the law of exponent. Any number raised to 0 is always 1. Computation in here will always tell to you that the result will give you the y-intercept or the value of the y-intercept, wherein we have in here point 0 and 1. The next thing that we will be looking into is, what if my x is positive 1? What would be the result? That is the same as 1.5 raised to 1. As what we have said in the exponential law, any number raised to 1 will always be the number. So what would be my point? My point is located at 1 and 1.5. What about if my x is 2? So I will be having f of 2 is equal to 1.5 raised to 2. It will give me a result of 2.25. And where is my point? My point is located at 2 and 2.25. The next thing to evaluate is, what if my x is 3? So I have in here f of x is equal to 1.5 raised to 3. What would be the result? It will give me a result of, I have in here 3.38 as my y, and so my point will be at 3 and 3.38. Next, last thing to evaluate is the value of x, which is the same as 4. So if my x is 4, f of x will be 1.5 raised to 4. What would be the result? The result would be 5.06. And what would be the location of the point? It will be located at point 4 and 5.06. To graph the exponential function that we just computed, to graph the exponential function that we just computed a while back, now we are going to summarize the result into table. So we have in here the summary of our evaluation. If I have x as negative 2, my result would be 0.44. If my x is negative 1, the result of the function would be 0.67. And if I have 0 as my x, my y will always be 1. And again, 0 and 1 is always the y-intercept of the exponential functions involved. So let's focus now our attention with the graph. So I have in here the graph of the given function or the evaluated function. So you will notice in here that if I have negative 2, my result would be at 0.44. So it is in here. The next one would be if I have negative 1. So here is my negative 1. My y would be 0.67. So as you can see, the point is located in here. 0.67. 1 is above. Next, if I have 0 and negative 1, so you will notice the location is we have in here. So the location of the point is in here. Meaning to say, this is already the y-intercept of the function. The next one would be if I have positive 1, it will give me a result. If I have positive 1 in here, it will give me a result of y which is 1.5 located in here. Okay. The same if I will be having 2, the value of my y would be 2.25. And if I have 3, so I have in here the x which is 3, the value of my y would be 3.38. And so if I have 4, my y would be, that is the same as 5.04. So this is the graph of the function f of x is equal to 1.5 raised to x. So you will notice the graph will be coming from the left going to the right, but there is the exponential increase, or there is the exponential rise of the graph. So if I say exponential rise of the graph will always a curve. It will not be a line. So to describe visually the word exponential increase. So to analyze the graph that we just had a while back, you will notice in here that we can see the properties that we just discussed. So the domain of the function or the exponential function are all real number. So where is that located in our table? I have in here from negative 2 to positive 4. It does not mean that these are only the domain of the function, but as I said, the domain are all real number. These are just sum of the domain. The next one would be, it says in here after having now the domain of the function and evaluation of the function, we can have now the result of the function, which are 0.44 up to 5.06. These are called to be now the range of the exponential function. Another one would be the y-intercept. The y-intercept is always located at 0 and 1. So we have in here. So the y-intercept is located in here in your graph. So I have in here the location. Next, if I have that y-intercept, I also have a property of an exponential function which is called to be a one-to-one. One of the property of the exponential function is a one-to-one function. Why? Try to imagine this line. Okay. Ayan. So you will notice that when this line moves down, go up, goes down again, goes up, the intersection of the graph I have in here and the line will only at one point, exactly one point. So meaning the exponential function pass through the horizontal line test. Now another property of the exponential function is the horizontal asymptote. So you will notice in here, my horizontal asymptote will be at line y is equal to 0. So line y is equal to 0. So I have in here. So see that line? Okay. So that is the line y is equal to 0, which is considered to be the horizontal asymptote. Why horizontal asymptote? Because when this graph will go down to your left side, it will not touch the line. It will not touch the horizontal asymptote, but it will come closer and closer to the horizontal line, but it will never touch that horizontal line. Why? It is because it is called to be now the asymptote of the one-to-one functions we have. The next thing that we will be looking into is the horizontal asymptote. The definition would be, it is a line that a graph function approaches as the value of x gets very large or very small. Now to understand this definition, allow me again to have a sample. So I have in here a function or exponential function f of x is equal to 2 raised to x. So let's try to evaluate this one and try to illustrate in a graph. So in here, we will evaluate. So how do we evaluate? Look at our substitution. If my x is negative 2, I will just replace this x. So I have in here. The same true that because this is x, the same as x, I will just replace this exponent x with negative 2. So that is how to evaluate the exponential function. Let's continue. So if I will be evaluating the exponential function, I will be having a result which is f of x is the same as f of negative 2 is equal to 2 raised to negative 2. Now the result of that would be 1 over 2 raised to positive 2. How come this is the result? Because in the laws of exponent, if our exponent is negative, we try to make it positive. And so how are we going to do that one? We will bring down this number as our denominator. So what is left if this will be our denominator? What is left is 1. And what will happen to the exponent if we will bring it down to the denominator? It will already be a positive. So the result would be 1 over 2 raised to positive 2. And it will give you that is the same as 1/4. Now, what about if we consider evaluating the function and plotting this one? So I have in here the original function. F of x is equal to 2 raised to x. If I have negative 2, it will give me 1/4. So that is the same as this one. What about if I have negative 1? My result would be replacing this one, f of negative 1 is equal to 2 raised to negative 1. It will give me a result of 1/2. What about if my x is 0? My x is 0 as according to the law of exponent, any number raised to 0 is always 1. Next, what about if my x is positive 1? So this would be positive 1. What would be my y? My y will always be 2. Why 2? Because in the laws of exponent, any number raised to 1 will always be the number. So in here, 2 raised to 1 will always 2. Next, I have in here my x to be 2. The result would be what? 4. Okay, so that is the same as 2 raised to 4, it will give you 2 raised to 2, it will give you 4. Next, if I have 2 raised to 3, it will give me 8. So how is the graph of this one? The graph of this one is we have in here. So you will notice if I have negative 2, my result, my y would be 1/4. Where is that negative 2? This is the negative 2. So my y is 1/4. As you can see in our graph, this is my 1. So where is my 1/4? Most probably it is located in here. So in here, so the intersection of my y and then x, it is located in here. The point is located in here. And what is the name? Negative 2 and 1/4. What about my negative 1? If my x is negative 1, so I have in here the x is negative 1. It is half. Okay, so we have in here my y would be 1/2. So as you can see, if this is my point, as you can see, it is located between 0 and 1, which is 1/2. The next one would be, what if my x is 0? What would be my y? So as you can see, if my x is 0 located in this uh, graph, you will notice that my y would be 1. So this is the 0 and 1. And so on and so forth. Continue having my x to be 3. So I have in here my x, which is 3. My y would be 8. So where is the point? It is located in here. So this is my 8. This is my 3. So that is the point 3, 8. So you will notice the graph is coming from the very top from the right, going down to the left, going down to the left, but it will turn to the left in here. Now, you might be saying, this graph will touch this line X. What is this? This line X is considered to be our horizontal asymptote. Okay? It will not touch this horizontal asymptote. Okay? So that is the graph of the exponential function, which gets closer and closer to the x but never reaches it, because f of x is equal to 2 raised to x will never result to 0. That is the very reason that the horizontal asymptote and the graph will never touch each other. Let's continue. So that is the horizontal asymptote. So we have in here another equation, or shall we say another function, which is the same as f of x is equal to 1.5 raised to negative x. You might be saying we are considering the same problem. No, we do not have the same problem in here. Our function has an exponent of negative x. A while back, the exponent is positive x. That's the reason why I told you a while back that please bear with this problem. You compare them and see the difference. The first one is f of x is equal to 1.5 raised to positive x. Our problem today is f of x is equal to 1.5 raised to negative x, and what would be the difference? Now, considering our computation, again, let's try to have our table. I will be making use of the same domain. Again, what is the domain? Any real number. And so I will be using the same assumption of x. So my x would be from negative 2 to positive 4. And of course, I will evaluate them. Okay. So if I will evaluate, what if my x is negative 2? Well, of course, the result would be 1. The result would be f of negative 2 will give me 1.5 raised to negative multiplied by negative 2, and so it will give you positive 2 as the exponent, so it will give you a result of 2.25. That would be the point. What about this one? If my x is negative 1, the result would be 1.5 raised to negative multiplied by negative 1. It will give you positive 1 as the exponent. So what would be the result? It will give you the same base, that is 1.50 or 1.5, and that would be our coordinate, negative 1 and 1.50. The same, if my x is 0, the result would be 1.5 raised to 0. It will always give me a result of 1. Okay, considering or assuming that we have already evaluated this one, okay, you observe and try to follow it with your calculator. Okay, it will give you a result of 0.67. My point would be 1 and 0.67. Next, if my x is 2, the result would be 0.44. So my point would be 2 and 0.44. What if that is 3? Okay, 1.5 raised to negative 3 will give you 0.30. So my point would be 3 and 0.30. And what if my x is 4? The result would be 1.5 raised to negative 4. That is 0.20. Yeah. Now, after having the evaluation of this function, you will notice that the next thing that we're going to look into is its graph. Okay, so what would be the graph of the given function? F of x is equal to 1.5 raised to negative x. Okay, here is its graph. You will notice that it is the opposite of the graph of the exponential function we computed a while back. But you will notice there is the exponential decrease. So from left to right, and we have in here. Uh, you will notice that my graph will be coming from the left side going down to the right side, but you will notice that there is what we call now the exponential decrease. And so you will notice in here, as it goes down, it will never touch this y, which is equal to 0, or line y which is equal to 0. Why? Because this is the horizontal asymptote. Now let's try to consider the points. Where are the point located? And so here, the next one, negative 1 and 1.5. So we have in here. Next, 0 and 1. We have in here. And next, we have in here. Okay, where is the point 2 and 44? We have in here. Another point, so that is 3 and 0.33. So it is located in here. Okay, another point. And the last point is 4 and 0.20. It is located in here. So the 4, and we have in here the point. So you will notice it is actually the opposite of the graph of f of x is equal to 1.5 raised to positive x. It is the opposite. Let's try to see the comparison of the graph. So here is the comparison of the graph. This is the graph of f of x, which is equal to 1.5 raised to x, positive x. and this is a graph of the function f of x is equal to 1.5 raised to negative x. You will notice that they are opposite. This graph is considered to be a graph of an exponential function, which is the representation of the growth model. So in the growth model, there is the exponential increase of our function. How about this graph? This graph is the graph of what we call now the decay model. When we say decay model, there is the exponential decrease of the function. Okay, exponential decrease of the function. Okay, so that is the comparison of the exponential function we have a while back and the one that we just computed. So f of x is equal to 1.5 raised to positive x. The other one is f of x is equal to 1.5 raised to negative x. Their graphs are opposites. The first graph we have in here is called to be the growth model or the graph of the growth model. The other one is called to be the graph of the decay model. Okay, decay model. Okay, so this is the comparison of the graph we have. Now, again, when we are talking of the growth model, the value of the b must be greater than 1. Okay, the value of the base must be greater than 1. And of course, the exponent is always positive. How about this one? Okay, decay model, our base in here is actually less than 1 because our exponent is negative. Okay, so that is the reason why there is the exponential decrease of the function. Again, before we end this lecture, I hope I shared to you ideas about exponential function or the graph of the exponential function, especially the comparison of the growth model and then the decay model in my humble capacity. Please click subscribe button and click the notification bell so that you will always be notified when I will be posting a new lesson. Again, thank you for listening.